All right. So today I gave the kids the red equation and I said this is a vector and I want one that's perpendicular to it. It took a while, but a group came up with one that was perpendicular to it. Now my challenge to them next is how do you figure out a way of checking that two vectors are perpendicular to each other? And one of the groups got it pretty quickly. Another group pretty quickly after that thinks they have it. How many of you think you have it now? All right, a bunch of groups. All right, so I'm going to try your group. Tell me what your description is for using this formula to somehow check that quickly whether two things are perpendicular to each other.
So if something is perpendicular to something else, and there's an angle of 90 degrees between them.
Ooh, I can tell you're on the right track. He says there's a 90-degree angle here between the two. Okay, go ahead.
So cosine of 90 is 0.
So what are you saying? If that is 0, I bet a lot of you never even typed in cosine of 90 and didn't realize that's 0. Does that change things a bit? Okay, keep going.
So the dot product of AP has to.
What about these guys?
It cancel out because it's multiplied by.
Yeah, you're multiplying by 0, so their lengths doesn't matter. And wouldn't you agree that if I'm saying they're perpendicular, their lengths don't matter? Magnitudes are lengths, right? I don't care if this is really short and this is really long. They can still be perpendicular, right? So lengths don't matter. And what does matter is that, as you said, how many groups had it right? We can trust you that the dot product had to be 0. All right, good. So 4 or 5 groups figured that out. So now the rest of you, at least, yet struggled with the problem for a while. And the research shows that if you struggle with the problem for a while, and then you're told the answer, you remember it better than if you never even thought about it and somebody just says, hey, by the way, if the dot product is 0, you'll remember it better now that you struggled to try to figure it out. And now know the dot product needs to be 0. All right, so let me tell you a different one and then see how quickly you can come up with it. Remember, where it starts does not matter. 214 plus t times 10 negative 3. You can find me really quickly, you can find me a vector that is perpendicular to that by using that whole dot product thing. And I want to give you a hint. Just start with any vector and then go, oh, this one's not, because the odds of you guessing one that are perpendicular is like 1 in a million. But you can tweak your guess really quick and easy and then find, oh, now if I tweak this number, now my dot product is 0. All right, so try to find me one that is perpendicular to that. All right, I have a proposal from a group, and they say 301 for this part of the vector. 301 would work. All right, now let me check it. Dot product. 3 times the 1 makes? 0 times anything makes? And negative 3 times 1 makes negative 3. So I have 3 and negative 3 and 0. Add them all together, I get 0. Cool. Is that the only answer? No, there's like a million answers that would work. So do you think I would want to put a test question on there that has 8 million possible right answers? No. How would you make the test question if you were the teacher to see if the kid could come up with a vector that's equal to another vector? But I didn't want to have 8 million unlimited possible answers. Well, you'll see one in the packet that I'm going to hand out later. Does anybody have an idea? Yes. Okay, but then the variables, if I solve this A, B, and C, could be anything. Not anything, but there's like literally an unlimited number of possible answers. Yes? Restrict the values. So like, for instance, I want this to be 0, I want this to be 2, and I want to know what that last one has to be. You get what I'm saying? Then there's only one possible answer, isn't there? Would you please figure out what that one possible answer is? What's this got to be then? Yeah, I'll check here.
Negative 1, negative 2, 1.
Student wants to know if negative 2, negative 2, 1 would have...
Negative 1, negative 2.
Say them again.
Negative 1, negative 2, 1.
All right. You wanted to know if this one would have been a dot product of 0 and therefore perpendicular. So that would be negative 1, 0, and negative 3. That does not add up to 0. The middle one is 0. I think you were thinking of 0 as a 1. All right. So the question mark here, the question mark I gave you, do you get, it's really like a little equation. This times this plus that times that plus that times that has to equal 0. And so what's it got to be? 0. Raise your hand if you had 0. Okay, good. So there is a explanation about what kind of vectors? Perpendicular vectors. Is there only one vector that's perpendicular to this vector? No, there's like a gajillion. But their dot product will always be 0. Okay, good. So that's a new thing for today. There's a lot more coming in the video that I record tomorrow, and that'll be the official review for the test video where I go over everything we've learned. I try, not everything, but I'll try to cover a wide variety of things we have learned since the beginning of vectors. Today, it's a work on this packet day, and it's a packet just because we left a room to work. Okay, so there's space between the problems and stuff. It's not incredibly long, and you have a lot of work time. This is called Vector Review Problems. It's green for those kids that are gone today, and I'm handing it out right now. That's all there is for today's video. If you want more review, watch tomorrow's.